Let's begin to our 10 questions part. So for our first question is 6 tan square x over 2 times sine square x minus cosine square x plus 1. So in this kind of questions, as you can see here, we have sine square x, cosine square x, right? So we know that sine square x plus cosine square x is equal to 1, right? So here, instead of this expression, actually when I leave here sine square x alone, it will be sine square x, which is equal to 1. I will put this cosine square x to other side, and it will be minus cosine x. As you can see here, we have minus cosine square x plus 1 also we have in our question. So it means that instead of this expression, I can put only sine square x. So when I put here sine square x, our question will be like this: 6 tangent square x over here 2 sine square x. This one is plus sine square x, so it will be 3 sine square x. Okay, so let's simplify this. This will be 2. So here we will have 2 tangent square x. I can write this as sine square x over cosine square x, right? Because tangent is equal to sine over cosine. And after that, here times this 1 over sine square x. So here this will cancel out each other, and here we will have 2 times 1 over cosine square x. Also we can write this as, we know that 1 over cosine x is equal to secant x, right? Secant x. So in this we can write this as also 2 times secant square x. So this is the answer for our first question. Let's continue with our second question. Here we have 5 over cosine x is equal to 6 over sine x, and cosine x is asked. So let's first start with doing the cross multiplication here. So here we will have 5 sine x is equal to 6 cosine x. Okay, so from here we will write this like this: sine x over, when I put this one on the other side, sine x over cosine x, which is equal to 6 over 5, right? When I put this 5 to other side. So sine x over cosine x, what does this mean? This is equal to tangent x, right? So our tangent x is equal to 6 over 5. So in this kind of questions, it is better for you to draw your right triangle, okay, to see the angles and to find the other trigonometric functions. So let's do that. Let's draw our right triangle here. So this is our right triangle. Let's say here is our x angle, okay? So our tangent x is equal to 6 over 5. So which means opposite side over adjacent side, right? 6 over 5. Tangent is equal to opposite side over adjacent side. So what is asked in this question? Cosine x. So to find cosine x, I need the value of hypotenuse here. So how can I find that? I know the formula for that. It is 5 square plus 6 square is equal to, let's say this is a square. So here this is 25 plus 36 is equal to a square, and this is 61, right? Yes, this is a square is equal to 61. So our hypotenuse is equal to square root of 61. So cosine x is equal to adjacent side, which is here 5, over our hypotenuse, which is equal to square root of 61. Now we are on the third question. Here we have cotangent p over 3 over tangent p over 4 plus sine 5p over 2 times cosine 2p over 3. So in this kind of questions, the easiest way is to convert radians into the degrees. Okay, so instead of p here, we will put 180 degree. It will be much easier. So let's do that. When I put 180 instead of p, I will get here cotangent. It will be 180 over 3. It's 60 over its tangent, p over 4. It's 45. So this is tangent 45. And then plus sine, when I put 180, 90 times 5, it's 450 degrees. These are, yes. And then I will close my parentheses, and then here we will have cosine. When I put 190, it will be 60, so it will be cosine 120. So we know the values of like cosine 30, cosine 60, right? Sine 90. We already know these values. So let's use them to find our solution. So here we have cotangent 60, right? So cotangent means cotangent is equal to cosinus over cosine over sine, right? So here we have cotangent 60, which is cosine 60 over sine 60. So we know that cosine 60, sine 60. So cosine 60 is equal to 1 over 2. Sine 60 is equal to square root of 3 over 2. So here we will have square root of 3 over 3. Okay, you can, if you want, you can also memorize this value because you will use also this one a lot, but this is the logic. If you don't want to remember, you can use just this formula to get this answer. So cotangent 60 degree is actually equal to square root of 3 over 3. So let's put here, it's square root of 3 over 3 over tangent 45 degrees. So tangent also is equal to sine 45 over cosine 45, right? So I know that sine and cosine 45, they are equal to each other and they are square root of 2 over 2. So tangent 45 degrees will be 1. So here it will be 1. Okay, plus sine 450 degrees. So here we need to find its principal angle. Okay, we subtract the multiplies of 360 from 450, and here which is equal to 90, right? When 360, so yes, here we will get 90 degrees. So instead of sine 450 degrees, actually I can write sine 90 degrees, and that is also equal to 1, right? Because 90 degree is here, and here, since it's sine axis, we know that it is equal to 1. So our sine 90 degree is equal to 1. So I close my parentheses. And now we have to find the value of cosine 120. So how do we do that? As you can remember, let's remember our unit circle. Okay, so for cosine 120, I can actually write this as cosine 180 minus 60, right? So 180, it's on this line. So on this line our function doesn't change, so its function name is the same, so it will be cosine, right? So after that, what we do, we first look its name, okay, its function, and after that we will look the angle, which is here equal to 60. Okay, I put the 60 here, and the last step is to look its sine, right? Remember these 3 steps? These are very important. Don't forget these steps. So here our last step is to look its sine. So here, how do we do that? Cosine 120. So 120 is somewhere here, right? Because yes, let's say here is 90 degrees, so here 30 degrees, so here our cosine 120. So here this is our cosine line, and as you can see here our cosine value is on the negative side. So that's why this will be actually equal to minus cosine 60 degrees. Okay, so instead of cosine 120 degrees, I can use the value of minus cosine 60 degrees, which is equal to, I know that cosine 60 is equal to 1 over 2. So here we will get minus 1 over 2. So let's write it here. It's my times 1 over 2. Sorry, it's minus 1 over 2. And from here, this is square root of 3 over 3 over 3 over 1 plus 1. So we will get here square root of 3, okay, plus 3 over 3 times minus 1 over 2. So from here we will get minus square root of 3 plus 3 over 6. Sorry, I didn't have that much space on this paper, but the most important part is for you to understand the logic. Let's continue with our fourth question. Here we have our trapezoid, and it said AB is parallel to DC, so cosine alpha is asked. So in this kind of questions, first actually it's better for you to start with draw another parallel line here. Okay, so let's do that. When I draw this parallel line here, because as you can see, to find cosine alpha, I need a right triangle, right? But here there is no triangle, there is nothing that I can find the value of cosine alpha. So let's try to draw this parallel line, and we will have one triangle here, and then we will see if we will be able to find another right triangle to find the value of cosine alpha. So let's do that. When I draw this parallel line here, so if this side is equal to 6, it means also here is equal to 6, and this side is equal to 4, which makes this one is equal to 4, and since this side is 14, this is 4, and this will be 10. So as you can see, I got here 6, 8, 10 special triangle, which means this angle has to be equal to 90 degrees, okay, because this is a special triangle, okay. So as you can see, we provide our right triangle here. So now let's see what we can do to find the value of cosine alpha. So here, if I say this angle, let's say it's beta, okay. So since this AB and DC, they are parallel to each other, it means that alpha plus beta is equal to 180 degrees. Okay, so instead of alpha, actually I can write 180 minus beta. Okay, so which means cosine alpha is equal to cosine 180 minus beta. Perfect. Why? Because beta is in the right triangle, right? So I can easily find the value of cosine alpha now. So let's see here. So when I draw my unit circle, okay, so our first step, what was it? It was the trigonometric, the name of the function, right? So it is cosine. When I look at the cosine line, here is our cosine line. Don't forget here the function name, it doesn't change. So if it is cosine, it will stay as cosine, okay? But when we look at this line, which is our sine line, if, for example, if here is cosine, it will be sine, okay? It will change. But since we are here, it's cosine, it will stay as cosine, okay? So first step this. And the second step is we will look at the angle, the angle. And here we have beta, okay? So we will write beta. And our last step is to look its sine. So it's cosine 180 minus beta. So 180, it's here, right? So 180 minus beta, it will be somewhere here, okay? So here, as you can see, our cosine value is on the negative side, which means this will be equal to minus cosine beta. So as you can see, we found actually our answer. It's cosine alpha, which is equal to minus cosine beta. So here we have our right triangle, here we have our beta angle, and we know that cosine is equal to adjacent side over hypotenuse. So here it's minus, don't forget this minus sign, and our adjacent side is equal to 8 here over our hypotenuse is equal to 10. So it's minus 8 over 10, or when you simplify this, it's minus 4 over 5. So this is the answer for our fourth question. On our fifth question, we have tangent 3p over 2 minus arc cosine 2 square root of 2 over 3. This is asked. So in this kind of question, when you see arc cosine, okay, these inverse trigonometric functions, let's name this one as like x. Okay, we always do that for our first step. And then let's rewrite our question. It will become tangent 3p over 2 minus x. Okay, so this one, how can I rewrite this one? Actually, to understand better, instead of p here, we can put 180, right? So which will become tangent. When I put 180, it's 90, 270 minus x, right? So when I draw my unit circle here, so 270, it's here, right? 270. So when I want to rewrite this one, I know that on this line, okay, our function name, it changes. So as you can see here, we have tangent, it will become cotangent, our first step. Don't forget, we are looking its line. Okay, so we will be able to understand if we need to change its name or not. So here, yes, we need to change its name since it's on this line. Okay, so it was tangent, we make it cotangent. And then we are looking its angle, which is here equal to x, okay? And then we are looking at its sine. So here, tangent 270 minus x. So here is 270 degrees, right? So minus x, it will be somewhere here. Okay, so tangent is equal to sine over cosine, right? So here our sine, as you can see, it's on the negative side, and also our cosine is also on the negative side, which means negative minus sine over minus sine, which will make it positive sign, right? So which means our tangent value here, it will be positive. So it's plus cotangent x. So actually we need to find the value of cotangent x here. Okay, so let's get back to our question. So x is equal to this inverse trigonometric function. So let's write them here. So arc cosine 2 square root of 2 over 3 is equal to x. So how we do this? We switch their places, right? So I will put this here, and this one is here, and it will become arc cosine will become cosine. Okay, so it will become cosine x, which is equal to 2 square root of 2 over 3. So we don't know any angle, right? Any value of cosine of any angle which is equal to 2 square root of 2 over 3. So in this kind of situations, it's better for you to draw your right triangle, because we need to find the value of cotangent x. Okay, so let's say here is our x angle, and cosine x, it's adjacent side, which is here, okay, over hypotenuse. So our hypotenuse is here, 3. So I can find this side also. So it will be 9, because 3 square is equal to 2 square root of 2. When I take this square, it's 8 plus, let's say here's a square. So here we will find the value of a is equal to 1. So this side is equal to 1. So now we can find the value of cotangent x, which will be equal to, cotangent is equal to adjacent side, which is here equal to 2 square root of 2 over, it is opposite side 1, which is equal to 2 square root of 2. So this is the answer for our fifth question. Okay, here we have sine 3x over sine x minus cosine 3x over cosine x is asked. So we will simplify this expression. Now let's first start with these denominators. Let's equalize their denominators, and here it will become cosine x. We will multiply this one by cosine x and this one by sine x. And here we will have sine 3x times cosine x minus cosine 3x times sine x over sine x times cosine x. So here, did you remember anything? When you look at this numerator, okay, you should remember from the sum and difference formulas. This is, you see, 1 sine, 1 cosine, minus 1 cosine, 1 sine, right? How was it? It was like this. Sine A minus B, okay, is equal to sine A times cosine B minus, you see, minus, and then it's cosine A times sine B, right? This formula, this comes from this formula actually. So when you look at, it's sine, cosine, cosine, sine, and since it's minus, it's also here minus. This is for you to remember. So it means that instead of this expression, actually I can write here A is our 3x, B is our x, right? So instead of this expression, I can write this as sine 3x minus x. You see, now everything is much easier. So still in the denominator we have sine x times cosine x. Okay, so here we will have sine 3x minus x, it's 2x, over sine x times cosine x. So here, instead of sine 2x, and here this is from double angle formulas, we can write 2 times sine x times cosine x, okay, over, this is sine, okay, cosine x times sine x, they're same. So as you can see, here we have sine x times cosine x. Also on the denominator we have cosine x times sine x. So we can cancel out these 2 and we will only get 2 as our answer. On our seventh question we have O is the center of the circle, cosine x is equal to 2 over 6 and sine y is asked. So when you look at the angle of y, it's not on the right angle, right? So we need to create one right triangle instead of to find the value of sine y. So how we can do that? Let's draw this line here. Okay, so as you can see, this angle, since this angle sees the diameter here, it's equal to 90 degrees. So we got our right triangle here. Why? Because it sees the diameter, right, from the circles. You should remember this rule. But still our y angle is not in the right triangle. So we should find something different, something else. So let's say we know the value of cosine x. Okay, let's say here is the angle of z. Okay, so since this angle sees this arc, its length is equal to 2z, right? This is another rule from circles. So if this angle is equal to z, the arc length that this angle sees is equal to 2 times of this angle, which is here is equal to 2z. So when we look at now our angle y, as you can see, it's actually, when we complete, I will draw like this because just for you to understand, because I need this space. So as you can see here, our y angle, it sees whole this 180 180, right, all these, and plus this 2z. So we can say that our y angle is equal to 90 plus z. Why? Because the angle that sees the arc, okay, this arc length, here it's 180 degree, 180, right? And plus also because it's all here. Okay, so as you can see, our y angle from here, it's 180, our arc length, and here we have plus 2z, and we have to divide it by 2 because this angle is the double size of this arc length. So we can say that our y angle is equal to 90 plus z. Okay, why I did this? Because I know that this angle z is in this right triangle. So why don't I use this, right? I should use this instead of to get the value of sine y. So let's continue. So which means instead of sine y, actually I can write sine 90 plus z. Okay, so let's find the value of this one. So when I draw my unit circle, 90, it's here, right? So as you can see on this line, the function name, it changes, right? So it will become cosine, and after that I'm looking at my angle, which is here equal to c, and the last step is to look its sine. So it's sine 90 plus z, so 90 plus z, it will be, it's 90 plus z, it will be somewhere here, and here it will be 90 plus z, so its sign will be plus. Okay, so it will be cosine plus cosine z. So as you look at this triangle, right triangle, okay, so here z, x and 90 degrees. So here we know the value of cosine x. So cosine x is equal to 2 over 6. Cosine is adjacent side, which is here, adjacent side is here, over hypotenuse, right? So our hypotenuse is here, which is equal to 6. So I can find the value of this side. It will become 6 square is equal to 2 square plus, let's say, a square. So it will be 36 minus 4 is equal to a square. So a square is equal to 32. A is equal to 4 square root of 3. Sorry, this is 3 because it's 16 times 2, it's 32. So we found also the length of this side. This is equal to 4 square root of 2. Now I'm able to find the value of cosine z, right? Which is equal to, z is here, cosine is equal to adjacent side, which is equal to 4 square root of 2 over cosine z, it's hypotenuse. Our hypotenuse is equal to 6. So when you simplify this, it's equal to 2 square root of 2 over 3. In this question, we have x is the element of the range 0 and p over 2, and x minus y is equal to p over 2. What is the value of cotangent x minus 2y when cosine x is equal to 1 over square root of 3? So let's look at this, our actually main question. Cotangent x minus 2y. First we need to simplify this because it looks so complicated, right? So let's do that. So we know that x minus 2y, x minus y is equal to p over 2. right? So here, when I leave y alone, I will get y is equal to, I will put this y here and this p minus 2, p over 2 over side, and it will become x minus p over 2. Okay, so here we have 2y, so let's multiply this by 2, and here 2y is equal to 2x minus 2x minus p, because these two they cancel out each other. So actually instead of 2y here, 2y, I can write 2x minus p. So let's do that. It will become cotangent x minus 2x plus p, right? So which is equal to cotangent p, it's minus x. So let's find the value of this one. Let's draw our unit circle. So p, it's 180, which is here, right? So here our function name, it doesn't change, so it will stay at as cotangent, and our angle, it's equal to x, and let's look at its sign, it's p minus x, so it will be somewhere here, right? So here our cosine on the negative side, our sine it's on the positive side, so it's minus over positive, it will become minus, so it is actually it's equal to cotangent minus cotangent x. Okay, because cotangent is equal to cosine over sine. And so here our cosine is on the negative side and our sine is on the positive side, right? So it's minus over positive, it will be minus. That's why it's minus cotangent x. So actually we need to find the value of minus cotangent x. Okay, so after this actually everything is much easier because we know the value of cosine x. So what should we do? We should draw our right triangle. Let's do that. So when I draw my right triangle here, let's say this is our angle x. Okay, I know cosine x is equal to 1 over 3, so cosine is the adjacent side, which is here 1 over hypotenuse, so here is square root of 3. So let's find the length of this side. Let's say it's a, so it will become square root of 3. Its square is equal to 3, so 3 is equal to 1 over a square. So here a square is 2. A is equal to square root of 2. So this side, its length is equal to square root of 2. So now I can find the value of cotangent x. Actually, I need to find minus cotangent x, which is equal to minus cotangent is equal to adjacent side. Adjacent side here is 1 over opposite side, which is equal to square root of 2. Also, this is equal to minus square root of 2 over 2. So this is the answer for our 8th question. In this question we have cotangent 3p over 2 minus x over cotangent 13p over 6 is equal to 1 over 3, and x is the element of the range of 0 and p over 2, and sine 3x is asked. So let's rewrite this expression here. Okay, so here we have cotangent 3p over 2 minus x. So instead of this, actually, how can I rewrite this one? Let's do that. So cotangent 3p over 2. Let's draw our unit circle first. Okay, so 3p over 2, it's here, right? 3p over 2, it's here. So here our function name, it changes, right? So cotangent, it will become tangent, our first step. Our second step, we will look at the angle, which is equal to here x. Okay, and our third step, we are looking at its sine. So here cotangent 3p over 2 minus x, so it will be here, somewhere here. Okay, so cotangent is cosine over sine, right? So here our cosine, it's minus on the negative side, over our sine, it's also minus on the negative side. So minus over minus, it will be positive, right? So it will be positive tangent x over cotangent 13p over 6. So as you can see, this is bigger than 2p. So we need to find its principal angle. How we do that? We subtract 2p, right? Because it's 2p is extra here. So let's do that. 13p over 6 minus 2p, which will be equal to 13p minus 12p over 6. So this is equal to p over 6. Okay, so which means instead of cotangent 13p over 6, I can actually write cotangent p over 6. Okay, this is also equal to cotangent 30, right? Because I can write 180 instead of p. So this is also equal to cotangent 30 degrees. So what is the value of cotangent 30? It's equal to cosine 30 over sine 30. So this is square root of 3 over 2 over 1 over 2, which is equal to square root of 3. Okay, so this is cotangent 30 degrees. So this is equal to 1 over 3. Okay, now how can I rewrite this? This is tangent x over, instead of this, I can write square root of 3. Actually, let's do this here. If I write square root of 3 here, when I do cross multiply, it will be 3 tangent x is equal to square root of 3. So tangent x is equal to square root of 3 over 3. So which angle has its tangent value as square root of 3 over 3? It is 30 degrees, right? So since we know the tangent 30 degrees is equal to this one, okay, so x is equal to 30 degree. You also should know these values like cotangent 30 degrees, tangent 30 degrees, cotangent 60, tangent 60, because as much as question you solve, you will be able to remember these values. So it will not be a problem for you. So here you should already know the value of tangent 30 degrees, which is equal to square root of 3 over 3. Okay, so now I know that x is equal to 30 degrees. What was the question? It was sine 3x, which is equal to sine 90 degrees, right? Because 30 times 3, it's equal to 90. So sine 90 degree is equal to 1. So this is the answer for our question. Let's continue with our last question. So here we have x is the element of the range of 0, p over 2, and square root of 1 plus sine x over 1 minus sine x plus square root of 1 minus sine x over 1 plus sine x is asked. So let's multiply these by their conjugates. Why? Because when I multiply these by their conjugates, I will get 1 minus sine square x, which is equal to cosine square x, right? So it will be much easier for me to take this cosine square x from this square. So it will be much easier to solve this question. So let's do that. When I multiply this by 1 plus sine x, and this one also by 1 minus sine x. Okay, so let's see what we have here. It's square root of, it will become 1 plus sine x squared over, so as I said before, it's equal to cosine square x. Okay, so here this will be cosine square x plus, here we will have 1 minus sine x square over, this will become 1 minus sine square x, which is also equal to, as I said before, this is cosine square x. Okay, so let's see, here we have I can write this as 1 plus sine x over cosine x plus 1 minus sine x over cosine x. Perfect. Now we can cancel these two because one is plus sine x and minus sine x. So on numerator we have 2 over, we have cosine x. We know that 1 over cosine x is equal to secant x. So instead of 2 over cosine x, I can write this as 2 times secant x. So this is the answer for our last question. If you don't understand anything till this question, please leave a comment and ask so we can help you out where you didn't understand. Thank you.